In atom inventory, we are going to talk about balancing chemical equations. After this, we should be able to see if an equation is balanced. We should also recognize if a chemical equation is unbalanced. And our ultimate goal is to be able to balance a chemical equation if it's not balanced. Brad, can you keep your head up? All the way up. Thank you. So, first off, this is tied into history as well. If you guys are history buffs, you may know Fritz Haber. Fritz Haber was able to produce nitrogen, take nitrogen and hydrogen to produce ammonia, which is NH3. Now, ammonia is a product that you guys may recognize as a cleaning product, but it's also used in making explosives. It's a predecessor to ammonium nitrate, which is oftentimes linked to explosives and being able to make explosives. And it was by doing this allowed Germany to be able to produce a vast stockpile of weapons in World War I. So,
Submarine.
What?
Submarine.
So, they were able to make weapons and it ultimately become a big power in World War I. So, what happens here is, so I'll stop for a sec. I should probably start recording all over. Let's take a look at this reaction. Let's look at this molecular model. You have nitrogen, which is N2, reacting with hydrogen, which is H2, forming NH3. So the reaction that looks like this, we look at this, we have 2 nitrogen atoms to start and 2 hydrogen atoms to start. We end with 1 nitrogen atom and 3 hydrogen atoms. So this breaks the law of conservation of matter and mass. Matter because we have a different number of the atoms before than we do after. So we can't just get rid of 1 nitrogen atom, and we can't just produce an extra hydrogen atom. Also, nitrogen's atomic mass is 14, so your total atomic mass here is 28. Here, your atomic mass of hydrogen is 1. So your total atomic mass in the reactants is going to be 30. So let me just write this in. So you have 14 is the atomic mass of nitrogen, and 1 is here. So your atomic mass total of your reactants, that means sigma, that means total of, is going to be 30. And your total mass of your products is 3 plus 14, which is 17. So it breaks the law of conservation of mass. You don't have the same mass after as you do before. And we can't just get rid of mass. Brad, you keep your head up. Okay? So that it violates these laws. Okay? Moving on. So let's consider this. So everybody look up here. Just look at the board for now. How many of each elements do we have? Nick, can you look up the board? Just stop that for now. Just look up here. So we start off, I have 2 nitrogen atoms in the reactants, 2 hydrogen atoms, and I end with 1 nitrogen atom and 3 hydrogen atoms. Okay? So that's how you know this is not a balanced reaction, because I have different amounts of each atom in the products and in the reactants. Okay? Do you guys see that? Does that make sense? Okay. So this is what we call an unbalanced reaction. Copy this bullet point down here after I talk about this. This is the only thing here you have to do. So since we don't have the same number of each atom in the products and reactants, it's not balanced. We have a different number of nitrogens and a different number of hydrogens. So that's what it means to be an unbalanced reaction. Oh, now continue recording. So moving forward, in order to make a balanced equation, we need to add groups of each substance. Now just look up here right now. Everybody look up here at the board. Okay? We need to add groups of each substance until the equation is balanced. So for instance, on the reactant side, look at this. How many nitrogen atoms do I have there? Two. I only have one on the product side. But I can't just add an N. I have to add a whole group of NH3. Shh. Please, just bear with me.
So it would be NH2?
Nope, it would be 2 NH3. Then we have to add 2 more groups of hydrogen. So we have a total of 2 N atoms and 6 H atoms in our reactants, and a total of 2 N atoms and 6 H atoms in our products. So, hold on. So overall, we have one group of N2. Look up here. Everybody look up here. Just look up here for now. We have one group of N2 and 3 groups of H2. And we have 2 groups of NH3. So that's where I get these coefficients. 1 N2, 3 H2 makes 2 NH3. That's a balanced equation right there. Okay? Do you guys see that? So we have the same number of each atom on both sides. 2 nitrogen atoms, 6 hydrogen atoms. Products, we have 2 nitrogen atoms and 6 hydrogen atoms. So this is the balanced equation. One group of N2, 3 groups of H2 makes 2 NH3. That's what it means to be balanced, to have the same number of each atom on both sides of the equation. Okay, does that make sense?
Wait, that does not make sense.
Okay, hold on. What's your question? So let's talk about some examples. Here's a different example. So let's copy these 2 down, give a little space in between, and then I'll go through how to do these. A couple different strategies. Let's go through a strategy to solve this. So Fe, let's look to our reactants. What are our different?
Oh, Killy.
Shh. What are our different elements? We have Fe and O here. Let's figure out how many of each. How many Fe's do we have in our reactants written, Chris? How many Fe's?
2.
Nope. 1. How many O's are in our reactants, Rafi? 2. Good. How many Fe's are in our products, Christian? 2. Christian. Okay. How many O's are in our products, Minnie? 3. So is this a balanced equation? It's not a balanced equation yet. So what we want to do here is we need to add change coefficients to figure out what we need to do. So let's start off with oxygen here. Now I need to figure out a number of groups of O2 and a number of groups of O3 that counts. What are those? Yeah. Solving the puzzle.
Okay, so you would have to get another product, or whatever that is.
Okay, so how many would I have total?
2 of those.
2 of these, so hold on, bear with me. And how many O2s?
You would need 3 pairs of them.
3 of these to make 3 of these. Let's figure out how that changes. So if I have 2 groups of Fe2O3, how many Fe's do I have?
1.
If I have 2 groups of Fe2O3?
I don't get the way you're doing it. I just realized.
Let me explain. If I have 2 groups of Fe2O3, in one group of Fe2O3, how many Fe's? 2. If I have 2 groups of Fe2O3, how many Fe's? 1, 2, 3, 4. Right? How many groups of O do I have? How many O's do I have total now? I have 3 here, 3 here. 2 times 3 is 6. Right? So now if I have 3 groups of O2, how many O's do I have? 6. Is this balanced yet? Is this a balanced equation?
No.
Not yet. So what do I have to do lastly? Uh-oh.
Oh, Kelly, you totally didn't bring it in.
Yeah, I know, but I didn't.
Activity time.
Activity time. Yep.
I
So
still
we did 4. That coefficient would be
I know
4.
what you do.
You know what?
You know what we should do?
Kelly,
Instead
Kelly,
of,
we should have like
Chris Babbitt, please.
Are you gonna do something you have to actually have?
Nope.
Never mind.
Just drop there.
Can you help me then?
Nope. Not now. You've already exhausted your chance for help.
Why?
Because you say inappropriate things and you make inappropriate noises. So therefore my class can function with you in it. So you're gonna have to either behave in class or figure it out on your own.
I'm in class.
Nope, get out right now. See? A good example of you not being inappropriate.
Kind of how it's
Alright. So like, which one? The FE one? Is that the one we don't understand? FE. Look up here. If you understand perfectly how to do this, you can be quiet and work. If you don't, look up here. But be quiet. Don't distract other people. Okay. What did I say? Do you understand how to do this, Rafi? Okay. Christian, do you understand how to do this? Okay. So, FE. So this here, we have groups of FE. I have FE and O. Is this a balanced equation? Let's check it out. I have one FE on the reactant side and 2 O's. I have 2 FEs and 3 O's on the product side. So it's not balanced yet, is it? So what I have to do is I have to add more groups to balance it. So maybe this way will make it easier for us to understand. So what don't I have enough of on the product side? I don't have another FE. So let's add another FE.
Wait, I'm confused. There's 2 and 3. Is it the left side, left side, or right side?
No. So it's not balanced.
Is the product side on the right side?
Yeah, look here. There's the arrows here.
Yeah, so there's 5 on that side.
There's 5 FEs?
Are you talking about down there, right?
Yeah.
Those are how many FEs and O's.
So yeah, on the product side there are 2 FEs. On this side, on the product side.
Oh, I got you.
Okay. So I don't have enough FEs, right? So Nick and Christian, come on. I know, but don't distract other people. Please don't interrupt. Okay? But you were talking. Okay, don't talk. It's easy. You don't have to do anything. So FE here. I need more FEs, right? So now how many FEs do I have? 2. Right? I needed more FEs. So let's get rid of these first. So do I have enough O2s? O's on this side? No. So I have to add more O's. But I have to add groups in O2 because that's my substance.
So isn't it basically how you did the
Similar concepts, but different.
so they would both be six.
Yes, we have to both make them a common multiple, and that's effectively what you're doing. But hold on, bear with me, okay? Look up here. Look up here. Everybody look up here. Zach, look up here. Okay. So do I now I have 4 O's on this side. Because I have 2 O2s. But now I don't have enough O's on this side, do I? So I need more of this group. Fe2O3. So now I have 6 O's. I also have 4 Fe's. So now what do I have to add to this side? I have to add another Fe? Is that enough? No. Now I have 3 Fe's on this side, 4 Fe's on this side. One more. So I need a total of 4 Fe's. Good. Good. What about O's? I have to add another O2. So now I have a total of 6. So my balanced equation is going to be, no, they always have to be equal. So overall, hold on, my balanced equation is going to be how many Fe's? 4 Fe plus how many O2s? 6 O2s? I have 6 O2s. 1, 2, 3. I have 6 groups of O2. I have 1, 2, 3 groups of O2. Yep. Yep, 3 groups of these things. How many groups of these things do I have? 2. So I have 2 Fe2 O3s. Yep. Okay, does that make sense? So you're right in what you were talking about before. Well, yeah, that's. So the easier way would be.
Wait, can I?
The easier way would be just to find common multiples. Make sure they all end up equal. So. Yeah, that's exactly what you're doing, and then you have to multiply. I'll show you.
Yeah, but some of them have like
So.
3 different chemicals.
I know, it's okay.
So how do you?
So the easy way to balance it this way would just do a tally, 1, 2, 2, 3, and find common multiples. So what's a common multiple of 3 and 2? 6, right? So how many 2's do I need? How many 3's do I need? I need 2. How many of these? And then balance the rest. So it changes. So now I have 4 Fe's, 2 Fe2 O3's, 6 O's. Now I have 6 O's here, so 3 O2's, and now I just need to figure out a number to balance my Fe's. So how many do I need? 4. How many do I have? What do I need to multiply 1 to get to 4? 4. Now I'm balanced.
Okay, I have a question.
Yeah? What, like the next one?
No.
Yeah.
Um.
So like let's start with this one. CH4 plus O2 makes CO2
Yeah, that one.
plus H2O.
You read my mind.
So we have C's, H's, and O's here, right? How many C's?
4.
C's?
Oh.
No. You can think about that as C1H4. How many H's on this side? 4. How many O's? Now on the products, how many C's? 1. How many H's? 2. How many O's? 2. And how many there? So we have 3 total. 2 plus 1 is 3. So let's pick one to balance. Let's start with the hydrogens. I have 4 on this side. How many? I need to have 2 on this side. What do I need to multiply 2 by to get to 4? So I need 2 of these.
Wait, why did you start with H and not C?
Well, C's already balanced.
Oh, okay.
There's 1 of each. Okay. So I have 4 H's now. I have now, well, look at my O's. I have 2 H2O's. So how many O's here? Nope. If I have 2 H2O's, how many O's do I have?
So you would have to
I have
multiply 2 by 2
1.
H.
I have 2 O's here.
Oh.
So it's 2 times 1. 2 plus 2. So I have 4 O's. So now I need to make my O's balance and I'm good. How many O's do I need? Need two O2s. Not balanced. No. But look at this. So if I have CO2, this is C,
What do you do?
O, and O, right? And H2H2Os is OH, H, OH, H. So two H2Os is like that. So how many O's are in two H2O? 1, 2, 3, 4. O's, no, yes.
What did you do? 2 times 3 is
But
6, and then 3 times 2 is 6. Would be 12.
But you can't do that because you have O here and O here. Both groups have O.
So I don't get it.
Which part don't you get?
I don't think I get it.
The last part?
Yeah.
So let's go
How
back
you got like 4?
because I balanced my. Do you understand how I got my
Oh,
hydrogens?
wait. Hold on. Oh, okay, I see. Because that's in front of that one, which is under the H and the O.
Yep, but not this one right here.
Okay, so you just added one?
Well, no. So I wanted to balance my hydrogens, so I need two H2Os. Because I have 4 H's on this side, I need 4 on this side. I had groups of 2. Yep. So here I have my oxygens, and let me write this another way. I have 2 plus 1 oxygens.
But you didn't do anything to the C, so how'd you get 4?
Well, let's.
Only 2 O's. Because 2 times.
When you diagram it out for it, CH4 plus O2 makes CO2 plus H2O. So I have, my CH4 looks like this. C, I'm not even going to draw this draw that. So I have CH4, looks like that. Okay, plus O2 looks like this. Makes CO2 plus H2O. So how many H's do we have on the reactant side? 4. How many C's? 1. How many O's? 2. So I have to balance this out. It's not balanced, right? Because I have 1 C, 1, 2, 3 O's, and 1, 2 hydrogens. So if I want to balance the hydrogens, I need to add another group of H2O. Yep. So now I have how many H2Os? I have 2 H2Os there. How many O's do I need? I have O1, 2, 3, 4 O's on this side. 1, 2, 3, 4.
Oh. But wasn't it O?
Because CO2 has O and H2O has O.
I thought it was just
So I need 2 O's. No, if I have 2 H2Os, do I add more O's? Yeah. I double the whole thing. If I put if I have 2x plus 2, does the 2 just affect the x? No, it affects the whole thing. As usual. Nope. You have it? Oh, that's right. It's not bad. What? Hold on, it's just a finish this. Did you finish up the classwork? Yeah, you did. It's perfect. Yeah. So you didn't even have to do all the other stuff. But that's just there you go. Yeah. Well, no. Why did you add 2 there? No, there's 1. The ZN, the 2 only applies to the CL. So just get rid of that. Yeah. Do your tallies. Good for important units in chemistry. Oh, Sarah, this one's not right.
Yeah, I know, I tried.
Look, no, but try it.
No, try the best you can do, that's all you
No, but you can. So, where did it go? Yeah, I've never seen it. I'll dismiss you guys. Have a seat. Everybody have a seat. Oscar, come on in and have a seat.
I did it for us.
Do it correctly. Nick. There you go. Everybody have a seat. Have a seat. Have a seat. When all stands are up, you guys can go.
Hey, Jared. Do you have a piece of chocolate?
I have no chocolate. I have Starburst.
No.
Yeah, I don't like it either. It's freaking. Oh. I'm so aggravated.
You know what? It pisses me off. I used the microscopes. I needed them for a couple of weeks. And Rebecca, who I like really well, it must have been him. They got it from him. He came down and took them. I needed today. No note, no nothing. So that I could have planned. You know what I'm saying?
What happened?
I borrowed the microscopes. I asked
Yeah.
Diego who has the microscopes because I'm doing
Oh,
cells
yeah.
right now. And I borrowed Rebecca had it. So today I come in because we're going to look at onion skin cells that I brought. I was just going to get the dye, and I look, and the microscopes aren't there. No note, no email. People don't think, you know?
No.
So if I knew they were coming to get them today, if they needed them, write me last week, say, I'm going to need them this day. Share. Don't you think? It's just kind of weird.
Unbelievable.
I don't know.
Oh, I'm pissed off. My football picks. They had
Oh, what happened?
they so um
Are you losing?
well, I was doing great, but then they didn't come up. The spreads didn't come up.
Is it for college or
Thanksgiving.
NFL?
For NFL, for the NFL games, they came up with 0 on
Uh-huh.
Thanksgiving Day, and then they changed them to the final ones changed. So now it's just so frustrating.
Yeah.
So I changed my picks because it was said 0. Now it's back to.
Oh, I see what you're saying. Oh,
Yeah.
wow. Well, I'll tell you what, that was a one friggin' tight game.
Oh, I know.
That was, I mean, that, to me, that was, I'm on the edge of the couch to the very end of that. I'll tell you, had they not done all the stupidity they did, you know, with Brady talking to the ref and all that kind of stuff, that actually was something that could have happened. Because that was a good team. They really played tight. Come on, Dad, come on. La fábrica necesita un sistema de transportación para mover las partes y las máquinas desde un lado del edificio a otro. También una célula. Esto es otra función que está hecho por el citoplasma. ¿Okay? En la misma manera que la oficina mayor controla una fábrica, el núcleo es el centro de control de la célula. En una fábrica, la oficina mayor manda todas las instrucciones a la fábrica. En una célula, el núcleo manda las instrucciones que se llama ARN. ¿Okay? ARN. Es así. En inglés, DNA es ADN. RNA es ARN. Creo que eso es ARN. ¿Okay? Eso es la parte que usa ADN para hacer. ¿Okay? ¿Okay? Ahora, entonces, como el centro de la fábrica que manda las instrucciones a los trabajadores, entonces el núcleo manda, voy a mostrarlo, el ARN, ¿okay? Y otras moléculas que llevan información a la célula. El ARN contiene instrucciones que explican a la célula qué clase de proteína que tiene que hacer. ¿Okay? El ARN explica a la célula qué clase de proteína que tiene que hacer. ¿Todo el mundo tiene esto? Sí. ¿Okay? Estas instrucciones, Laura, ¿qué es eso? Okay. Estas instrucciones viajan a los ribosomas. Cada ribosoma es como una máquina en la fábrica que fabrica proteínas de las instrucciones que tienen del núcleo. Okay. Cada ribosoma es como una máquina en la fábrica que fabrica proteínas con las instrucciones que tiene el núcleo. De las ribosomas, las proteínas que van a estar soldados por la célula en el cuerpo, ¿okay? Mueve al aparato Golgi. En el aparato Golgi es donde ellos apuntan carbohidratos y lípidos para preparar las proteínas para sus proteínas. ¿Okay? El aparato de Golgi es un poco como un taller entre la fábrica que como hace los toques finales antes que ellos están listos a salir de la fábrica. Desde el aparato de Golgi, las proteínas están mandadas a sus destinaciones finales. Solo hay una cosa que tiene que completar en nuestra fábrica de la célula. Las células no pueden usar el poder de la compañía de utilidades, porque electricidad, gas. Entonces, ellos reciben su energía de dos organelos, la mitocondria o cloroplasma. ¿Okay? Las células reciben su energía de la mitocondria de un lado del edificio también una célula necesita esto. Esto también es una función del citoplasma. De la misma manera que la oficina mayor controla una fábrica muy grande, el núcleo es el centro de control de la célula. En una fábrica, la oficina mayor manda instrucciones a la fábrica. En una célula, el núcleo manda las instrucciones de ARN y otras moléculas que llevan información a la célula. El ARN contiene instrucciones que explican a la célula qué clase de proteína que tiene que hacer. Las instrucciones, entonces, están recibidas por las ribosomas. La ribosoma es como una máquina de la fábrica que hace las proteínas de las instrucciones que vienen del núcleo. De las ribosomas, las proteínas que van a estar soltadas por la célula, cuerpo, ¿okay? Mueven el aparato de Golgi, donde ellos están ajustados con carbohidratos y lípidos para preparar esas proteínas para hacer su papel en el cuerpo. El aparato de Golgi es como un taller especial en la fábrica que le da los toques finales a las proteínas antes que ellos salgan de la máquina. Desde el aparato Golgi, las proteínas están mandadas a su destinación final. La única cosa que necesitamos para completar nuestra fábrica de la célula es el fuente de energía. Las células no pueden conectarse a la compañía de utilidades. ¿Okay? Entonces, en la célula, ellos reciben su energía de un organelo que se llama mitocondria en la célula animal y otro organelo que se llama cloroplasto en la célula humana. ¿Okay? Entonces, la mitocondria usa esas moléculas para producir compuestos de alta energía para que la célula pueda usar esa energía en ella. En esta manera, la mitocondria son como una estufa que hacen aire. ¿Mejor? Ahora no. ¿Sí, no? complejo de Golgi, sí, el aparato de Golgi, el complejo de Golgi, ¿ok? Allá, el complejo, el aparato de Golgi junta carbohidratos y lípidos a las proteínas para prepararlos, para que ellos puedan salir de la célula, ¿verdad? Y entonces, ¿cuál es esto es el taller. Ahora, ¿dónde recibe la energía de la célula para hacer todo eso? De dónde viene toda la energía como la electricidad de nuestro página. Por cloroplastos de plantas. Mitocondria. Mitocondria. La mitocondria, entonces, ¿dónde recibe la energía? ¿Ok? Y por respiración, por la respiración de la mitocondria, entonces hace lo que es necesario para la energía. ¿Ok? Sí, más o menos. ¿Sabe una cosa? ¿Sabe una cosa, estudiantes? El huevo es el modelo que más funciona para el modelo de un ser humano. Porque la parte blanco, ¿okay? Es como baboso, ¿verdad? Es como el citoplasma. ¿Okay? Mira, el huevo es casi una célula. Como que está cosito.
Igual que cuando uno piensa en la yema, se bota.
Porque la yema tiene como membrana. Membrana que es parecido a membrana de célula. ¿No? ¿Okay? Esa es la cosa. Pero esa membrana también tiene poros.
Mi país eso lo ponen con mayonesa y mi mamá pone mucho. También que igual que el queso se le añade igual que el queso. Y cuando uno come con amigos hay lleva encima de la cabeza.
Bueno, yo en verdad tiene proteína. En la alimentación dominicana. Ok, mira, lo que vamos a hacer.
Ay, no, es
Lleva,
verdad.
escucha, escucha. Lleva esto a casa. Ok, ok. Complétalo. Puedes buscarlo en el internet, lo que sea, pero tiene que estar en la forma de quinoa. Ok. No, sí, pero no es la manera que se fue, es la estructura que es básica. Pero la manera que ellos pueden hacer. Sí. Ok. Si me haces el favor de levantar, no, guárdalo, guárdalo. Solamente voy a recordar que me mañana. La palabra del año, el pachón. Ahora para ti.